Hey everybody! In this video we are going to be using Kc to solve equilibrium concentrations. So in our past videos we've been learning how to write equilibrium expressions. So we're going to get a balanced chemical equation here and we'll get started. So we got some hydrogen plus some chlorine, and this is a reversible reaction to make hydrogen chloride. And we've been told that at some temperature that our Kc value for this reaction is going to be 120. That's a unitless value. All it's going to do is tell us a ratio of reactants to products when this reaction is complete at equilibrium. Because this Kc is bigger than 1, we know that it's going to favor the products, which means we're going to end up with more HCl than our H2 or Cl2. In previous videos, we solved Kc, but this time, instead of being given the concentrations at equilibrium, we're going to be given the initial concentrations. So our H2 is going to be 0.5 molar initially, and our Cl2 is going to be 0.6 molar, and our HCl, we're not going to put anything in that at all. And we put these in the flask, and we seal our flask with a little stopper, and then we put on our toque, and we go for a walk in the snow, and we go get a coffee, and we wave at everyone we see all the time, just like holding this little flask and letting it react away. And it's going to react some number of times until it's all done. How many times? We don't know yet, but it's going to react some number of times until it reaches equilibrium. Now, that some number of times is going to be our change. You see, each time this reaction happens, given this balanced chemical equation, if you did this reaction once, you would produce 2 moles of HCl, you would lose 1 mole of chlorine, and you would lose 1 mole of H2. If you get this, you get the whole thing. If we did this reaction 5 times, you would produce 10 HCl's. You would lose 5 Cl2s, and you would lose 5 H2s. That's how a reaction works. You use up your reactants, you produce products. If we did this reaction X times, how much hydrogen would we lose? Well, we lose 1 hydrogen every time we do the reaction. So if we did it X times, we would lose X hydrogens. It's a reactant, we lose it. Our chlorine, if we do this reaction X times, how much chlorine will we lose? We're going to lose X. If there had been a 3 in front of this chlorine, we would have lost 3X, because 3 chlorines for every time we do the reaction. Now that coefficient's important, because for HCl, if we do this reaction X times, we're actually going to gain 2X of our HCl, because each time we do the reaction, X is the number of times we do the reaction, we gain 2 HCl's. E, this is called an ice table, that's how you remember it, is our equilibrium. And that is to say, what will our concentration be at equilibrium? If our initial was 0.5 and it's going to lose X, our equilibrium should be 0.5 minus X. And for chlorine, 0.6 minus X, and for our HCl, it's 0 plus 2X. You don't need to write that 0, so it just becomes 2X. And these are going to be our equilibrium concentrations. But we don't know what X is. We don't know how many times this little flask is going to react while we go for our walk. That's what we need to solve. So I'm going to scroll down here a little bit and give myself some room because I'm going to write out a Kc expression, and our Kc expression for this is going to be our product, HCl, and since it had a coefficient of 2, it has to be squared. And if you need practice with Kc and creating these, there's actually some videos on how to do that. I can help you out with that. Our H2 and our Cl2. At this point, you should be able to make a Kc expression, and we're trying to solve for a concentration. If you filled that in correctly, you've created this Kc expression. Now we're going to fill it in what we know. What we were given Kc. Kc is 120. It's going to equal our concentrations at equilibrium. Well, what is our concentration of HCl at equilibrium? It's 2x. We're going to square that. Divided by, what is our concentration at H2 at equilibrium? Well, we started with 0.5. We lost x by doing this reaction x times. So our H2 is going to be 0.5 minus x. Our chlorine, 0.6 minus x. Well, if you've gotten this far, the chemistry is done. Hada! It's math time. We need to solve for this x. So I'm going to scroll this up and we are going to unleash our inner mathematicians and we're going to solve this out. To get rid of this denominator, the 0.5 minus x multiplied by the 0.6 minus x, I'm going to multiply it to the other side. We're going to end up with 120 multiplied by 0.5 minus x multiplied by 0.6 minus x, and it's going to equal, we can do the 2x squared, that's 4x squared. I'm going to FOIL this out. 120 multiplied by, we do the first, outer, inner, last. We're doing equilibrium calculations. I believe that you can FOIL. And it's going to leave you with 0.3, subtract 0.5x, subtract 0.6x, plus x squared equals 4x squared. And now we're going to multiply that 120 in, and it's going to give us 36 minus 60x minus 72x plus 120x squared equals 4x squared. Hopefully you see what's coming, because we're now going to subtract 4x squared and combine our like terms. We are going to turn this into a beautiful, beautiful little quadratic. Would you look at that? Now, if you've watched some of my videos on earlier math, I would work out this quadratic. I'm not going to plug this into the quadratic equation here today. I believe that you know how to solve a quadratic. If not, use your quadratic formula. You check out one of my other videos. You're going to get two answers here. Our two answers are x equals 0.685 and x equals 0.453. One of these is correct. How do we decide which one of these is correct? We can decide because our equilibrium concentrations, our H2 was equal to 0.5 subtract x, and our chlorine was equal to 0.6 subtract x. Clean that up. And our HCl was equal to 2x. And I just know my clever little cupcakes are looking at this right now and realizing, if I have 0.5 moles per liter hydrogen, I can't subtract 0.685. I will run out. We cannot make negative hydrogen, which means the 0.43 must be correct. The 0.685 is not the correct answer. The 0.453 is. We're going to get our final answers by plugging this 0.453 in for x, and our final answers are: concentration of H2 is 0.047 molar. Our concentration of Cl2, when we fill in this 0.453 for x, is going to be 0.147 molar. And our concentration of HCl, whose equilibrium concentration was 2 times x, is going to work out to be 0.906 molar. And there we have it. That is how we use a known Kc in order to solve the equilibrium concentration of all of our substances. If the only thing we know is what we put in the flask, shook it for a while, and this is what's left over once the reaction is all done reacting. Thank you very much, and hopefully I'll see you next time.